question 4 has, so it says the Golden Gate Bridge in San Francisco is constantly being repainted. It's estimated that the surface area of exposed steel needs to be painted is approximately 10 million square feet. Given that 1 meter is equal to 3.28 feet, convert the surface area. Okay, so if we think about this, guys, okay, if I had, let's say, 1 meter squared, is that equal to 100 centimeters squared? No. Okay. When I have 1 meter squared, I need to do the conversion from meters to centimeters twice. So we almost need to go back and say, okay, well, 1 meter is equal to 100 centimeters. So to get from a meter squared to centimeters squared, we need to multiply by 100 squared. Okay, so if we try and find out how many centimeters squared are in a meter squared, we're going to find out that it's, well, let's look at my meter square here. So it's going to be 100 centimeters times 100 centimeters. Okay, it's a meter square. So the meter square there is equal to 100 squared centimeters squared. Okay, so it's going to be the same thing here. So, okay, so if we have 1 meter equal to 3.28 feet. Okay, so 1 meter is equal to 3.28 feet. Okay, what that means is 1 meter squared is equal to 3.28 squared feet squared. Okay, so that's the conversion that I'm going to use in this question. So it says, convert the surface area of the bridge into square meters, and we're just using that it's 10 million. Okay, so we said when we are converting units, we put the unit that we've been given the amount in. So here we've been given it in square feet. We put that unit in the denominator of our conversion. So here my fraction that I'm going to be multiplying by is 1 meter squared over 3.28 squared feet squared. Okay, so that's going to be my fraction, and I'm going to be multiplying that by the 10 million square feet. So 10 million square feet. No idea what I clicked there. Feet squared. Okay. Okay, fab. So now that I have this, I can literally just put it into my calculator. So we can just ignore the units for a second and figure out what is 3.28 squared. Okay, so that's what's going to be on the denominator of my fraction. So 1 over 3.28 squared is going to be multiplied by 10 million. So when we put that into our calculator, we get out that's equal to, so 929,506.2463. Okay, and then it says, so now we have our answer. So that's how much it is in meters squared or square meters. And it says giving your answer in the form, and it's essentially is telling us that it wants it in scientific notation. So what was scientific notation? It means that I want the decimal after the first number, and then I say multiplied by 10 to the power of something. And the something we get from how many places the decimal moves. Okay, so I want to move my decimal from here to 1, 2, 3, 4, 5 places over. Okay, so it's going to be to the power of 5. Okay, now remember, when we move the decimal to the left, it's a plus number. If we moved that decimal to the right, it was going to be a minus power. Okay, so my new number here is going to be 9.2950624663. Okay, so the decimal point has moved. And to show that, I need to say by 10 to the power of, and then however many places it moved. So here it was 5. Okay. So now we have it in scientific notation. And then it says, give the value of A correct to 2 significant figures. So significant figures, they're kind of like decimal points, decimal places, but they include the numbers before the decimal as well. So 9 before the decimal is 1 significant figure, and then this, we only want one more number, so we just want 1 decimal place after the decimal. So we are going to have this round to 9 point, and then 2. Does it stay the same or does it increase by 1? Well, the number after it is 5 or more, so it increases by 1. Okay. So that is my answer here. Okay, that is how many square meters is in the Golden Gate Bridge in San Francisco, the exposed steel. Okay, and then part 2 says a litre of the paint used on the Golden Gate Bridge will cover approximately 5 square meters. This paint comes in 25 litre tins. Find the minimum number of tins of paint that will be needed to paint the entire bridge. Okay, so how much does this 25 litre tin cover? So if 1 litre covers 5 square meters, so 5 meters squared, okay, then 1 tin, which is 25 litres, covers 25 times the amount. So we are going to be multiplying this 5 meters squared by 25 to get that a tin covers 125 meters squared. Okay, so that's what 1 tin covers. So how many tins are we going to need to cover this amount of meters? So 9.3 by 10 to the power of 5. So we're going to just divide the values in. So I'm going to do the area of the exposed steel divided by the amount of meters per tin. So it's going to be 9.3 by 10 to the power of 5. Okay, divided by 125. So to type this into my calculator, remember, we literally type it in as 9. Okay, I'm going to call out the buttons as I type them in. So the numerator here, so it's 9.3. Okay, and then instead of saying multiplied, I'm pressing the button that's just to the left of the answer button. Okay, the one that looks like times 10 to the power of x. Okay, I'm pressing that. So it's 9.3. And then this button, and then I'm not pressing power. Okay, I'm literally putting 5 in. So 5 as the power. It doesn't look like the power in my calculator if your calculator is Casio. Okay, so that's my numerator, and then I am putting that over 125. Okay, so the answer that I get out there is, it actually works out exactly even, which is quite nice, is 7,440. So that's how many tins I need to paint this amount. Okay. Okay, so next question then says, well, same question. Next part says, solve this equation. So it's looking at our indices again. Okay, so we have 2 to the power of 9x minus 1 is equal to 8 to the power of 2x. Okay, we can't do anything in this unless we notice something like, if I said to you, let's say 3 to the power of 4 is equal to 3 to the power of x. What does x equal? Well, we'd know that x is equal to 4, that we could just look at the powers because the base here was the same. Okay, so we want to try and make the base of these numbers the same. So how are we going to do that? Well, I know that 8, how can I get 8 to be 2 to the power of something? I know that 8 is 2 cubed. Okay, so I'm going to use the fact that 8 is equal to 2 cubed, and I'm going to rewrite out this equation. So I'm going to write it out as 2 to the power of 9x minus 1 is equal to. So it's going to be 2 cubed to the power of 2x. Now, you need to open up your log tables. Well, you don't need to if you know the rules off. But you can open up your log tables. I think it's on page 21 or else page 11, where all of our rules are, and see what was the rule when we had a power and another power acting on each other. So they're not multiplying, they're not adding. So here it's like a power of a power. So if you open them up in your log tables, what we're going to see is that these multiply. So when we have a power here, so I'll write it as if it was coming up in our log tables. So it would have like a as the base. Okay, here, I'll get it open. Yeah, so it's on page 21. So it would have a as the base to the power of p to the power of q is equal to a to the power of p q. So when they're right beside each other, they're multiplying. So here, this is the relationship between the 3 and the 2x. So I can actually rewrite that with them multiplied by each other. Okay, so I can rewrite this out as 2 to the power of 9x minus 1 is equal to 2 to the power of 3 times 2x. Okay, now at this point, like, you can still simplify the powers and stuff, but also I have the exact same bases. I'm just going to cancel them out. Okay, so now what I have is 9x minus 1 is equal to 3 times my 2x. So I have 9x minus 1 is equal to 6x. Okay, so when it says solve the equation, we're just trying to find x here. Okay, so we're just trying to find x, so we can bring the numbers over, we want the numbers on one side and the terms containing a variable on the other side. Okay, so let's bring the 9x, let's try and get rid of that from the left side. So how am I going to get rid of a 9x that's in an addition sum? Well, I'm going to minus it. Okay, so it was in a sum, so I am doing the opposite of the adding, I am minusing it. So I'm going to end up that minus 1 is equal to minus 3x. Okay, so how am I going to find x if there is a minus 3 in the way? Well, the minus 3 is multiplying, so to get rid of it, I'm going to divide. So I'm going to divide both sides by minus 3, and I'll get, well, minus divided by a minus is a plus, and then 1 divided by 3 is just a third. And that's equal to x. So x is equal to a third here. Okay?